Okay, this is the last lecture for Unit 3. We're going to change gears a little bit here and look at factor markets instead of product markets, but still we'll keep this in this unit just because it's very similar to perfect competition, as you will see in a moment. But things are going to look a little bit different just because we're going to look at this from a different standpoint. So what you'll be able to do by the end of this lecture is determine the quantity of resources that will maximize profit. So how many resources to hire. So now we're looking at it, how many resources to hire instead of how much output to produce. And the way that we will do that is by using marginal cost and revenue analysis. So we have to define a few mathematical concepts first, starting with what we call marginal revenue product, or MRP for short, going forward. So the marginal revenue product is basically just how much extra revenue we're going to get from hiring one more worker or other input. So we'll use workers just to keep things simple, but this really applies to any input that could be hired in the production process. So you want to think of this as what is an additional worker worth? Like how much extra output am I going to get, but more importantly, how much can I sell that output for? And that's going to give you an idea of the value of an additional worker. So to calculate the MRP, we simply take the marginal revenue and divide and multiply by the marginal product. Okay. So if we're talking about, so for the time being, if we're talking about sort of perfect competition, then the marginal revenue is basically just the price. It's the price of the output. And then you multiply that by the marginal product. So for instance, if hiring one more worker is going to give me 10 additional units that can be produced, and I can sell each of those 10 units for $10, then the marginal revenue product of that worker is $100. They're going to bring in $100 of extra revenue to the firm, so that really kind of represents their value, so to speak. Okay. And once again, at any time, if I'm going a little too fast, feel free to pause the video. All right, now to complete the full cost benefit analysis, remember we need to be able to measure the marginal benefit, which again is the marginal revenue product, and then compare that to the marginal cost, which in this case is called the marginal factor cost. You may see this in some places as marginal resource cost, and they would abbreviate that as MRC. Those two things mean the same thing. So if you run into that anywhere, those two terms are used interchangeably. So this one's pretty straightforward. The marginal factor cost, or the marginal resource cost, is the cost of hiring an additional factor or resource, such as one more worker. Now think about that for a moment. What is the cost of hiring another worker? Well, usually, there's one small exception to this, but usually it's just the worker's wage. So the marginal cost of hiring an additional worker is that you'll have to pay them a wage, right? So that represents their cost. So then when deciding how many workers to hire, we could compare the benefits. How much extra revenue am I going to get to the cost? How much is it going to cost me to hire that extra worker? And again, for the time being, we'll assume that the marginal factor cost is equal to the wage. As you will see later on in a subsequent unit, there is one sort of small exception when that's not true, but we'll point that out at that time. Okay, so let's get into the reason we're doing this. How does a firm decide how many workers it should hire? And like all things, it's cost benefit analysis, right? So when we did how many, like for a consumer, how many units of a good should they consume? We just compared the marginal benefit against the marginal cost, right? Or the marginal utility against the cost of the good. Now it's very similar for a firm hiring workers. It just needs to compare the cost, which is generally the wage, to the benefit. Now, what's the benefit of hiring workers? Well, you can produce more output, and that output can be sold at a price which will bring in additional revenue. So that additional revenue is the benefit. So here's the rule, and it should make sense. you should keep hiring workers as long as the additional revenue from each worker is greater than or equal to the marginal factor cost of hiring that worker. Okay, so when these two are equal, you want to stop. So as long as your MRP is greater than your MFC, as long as the additional revenue is higher than the cost, keep hiring workers. When they're equal, you want to stop um, because what's going to happen is that the marginal factor cost will start to exceed the marginal revenue product, which means it's going to cost you more to hire a worker than the amount of additional revenue they could bring in. Now, why is that true? Well, remember, marginal revenue product depends on marginal product. And what do we know about marginal product? Well, it's diminishing based on the law of diminishing returns. So each and every worker you hire is going to bring in less and less additional output, which means their marginal revenue product will be falling. And there will come a point where that will fall below the cost of hiring that additional worker. And at that point, you obviously don't want to hire a worker that's going to cost you more to hire than the additional revenue they're going to bring to the firm. Okay. So let's sort of do a sort of simplified example of this, and you don't need to write this part down. So let's say you're operating a business, and let's assume we're going to sort of simplify things a little here. Let's say that you're selling your goods in a perfectly competitive product market, which means that the price is constant. So let's say your product price is $10. You can sell as many units as you want at $10. Now, further assume that you're hiring your workers from a perfectly competitive resource market or factor market, and that the wage is constant at $15. So every worker you hire, you have to pay an additional $15. So that represents their wage. So I'm going to give you some data, and the question that you're going to answer is how many workers should you hire to maximize profit? Okay, so let me give you that information now. And then I'll let you attempt this and then we'll go over it. So this is the number of workers that you can hire. And this is the total output that you can produce, depending on how many workers you choose to hire. Just by giving you this information, so and telling you that the price of the product is $10 and that the wage of your workers is $15, how many workers should you hire? And let me give you a hint. Consider how much you think each worker is worth. What is the value of each worker? So what you can do now is pause the video and see if, without me going over all of the steps, if you could figure out how many workers it would make sense to hire given this price and the wage. So pause the video and see if you can figure out the profit maximizing number of workers to hire. And again, just think about how much each worker is really worth. Okay, so I'm going to start going over this. So let's see if you were able to figure this out on your own. So first of all, a few things. Notice what's happening to total product here. Notice the first worker brings in 7 additional units of output, and then the next worker brings in additional 10 because we go from 7 to 17. So what's happening to total product? Well, it looks like from 1 to 2 workers, total product is increasing. We do know that total product is increasing, but at a decreasing rate. So you'll notice here it goes up by 10, but then it only goes up by, it looks like, what is that? 4 plus 3 plus 7, so an additional 7 units, and then an additional 3 units. So we know that total product is increasing at a decreasing rate, and that's pretty consistent with the law of diminishing returns. Now, why does this occur? Why do we see diminishing returns? You can pretty much sum it up in 2 words: fixed inputs. That probably means we have a building that's only so big, only so many tools and machines. So adding workers is going to give me less and less additional output. So the Y is essentially fixed inputs. And then can you spot 3 stages of returns here, if applicable? So if you'd like, go ahead and pause and see if you can determine the 3 stages of returns, all of which are evident according to this data. Okay, so um, what you will notice is that increasing returns pretty much run out after 2 workers. So after hiring the second worker, so the second worker has increasing returns because the first worker added 7 units, but the second worker added an additional 10, which is greater than 7. So pretty much from 0 to 2, we have increasing returns. But thereafter, we have diminishing returns. You'll notice that the additional output generated by each worker is decreasing. Um, so the sixth worker only adds 1. The fifth worker only added 2. So we're getting less and less returns. Now that is true up through the sixth worker. So workers 3 through 6 show diminishing returns. They're still adding output, but at diminishing rate. A seventh worker is negative marginal returns. Notice that we hire the second worker, our total output actually falls from 30 to 27. So the marginal product there was -3. So worker number 7 is the only one that exhibits negative returns as opposed to diminishing returns. All right, so here are your marginal products, which we will need. Notice we have increasing returns, and then diminishing returns, and then negative returns. All right, now what does this represent? Well, it tells you the productivity of each worker. It tells you the additional output you get out of hiring each worker. And as you will see, that's going to determine how valuable that worker is. But this isn't the actual value of the worker, right? Because this is just the additional units. But we can sell these units at some price. Now, what do we know about the product price? It's fixed at one price because it's perfect competition. So remember Mr. DARP, there's one price, and that's the same thing as the marginal revenue. So at a price of $10, however many units we sell, we can sell them for $10. So now we can use this information to calculate what we call our marginal revenue product, right, or MRP. Now, if you remember, your marginal revenue product is your marginal product times your marginal revenue. Now, keep in mind, your marginal revenue is the same as price in perfect competition. So it's just this number times that number. So for example, the third worker gives us an additional 7 units of output, each of which we can sell for $10, which means that worker can bring an additional $70 in additional revenue to the firm because of the extra output they help produce. So now the question is, how many workers should I hire? Well, now let's compare that marginal revenue product to the marginal factor cost of hiring each worker. Now, what do we know about that? It's constant at $15. However, if I hire another worker, I have to pay another $15. So that's a constant cost. So how many workers should I hire? Well, let's kind of go through each one here. First worker is gonna produce enough output that's gonna sell for an additional $70, and they're only gonna cost me $15 to hire. Absolutely hire the first worker. Same is true for the second worker. They'll bring in $100 in revenue, but only cost you 15. That's 75 in profit you get out of that second worker. Then let's see the third worker for sure, right? They bring in $70, they cost 15. Fourth worker, still makes sense to hire them. They bring in $30 extra in revenue. Just due to those 3 units, which we sell for $10 each, we have $30 in extra revenue. They only cost 15 to hire. For sure, let's hire them. Fifth worker, $20 extra in revenue. They cost me 15 to hire. For sure, I should hire that worker. But now let's look at the sixth worker. Sixth worker is going to give me 1 extra unit of output. I'm going to be able to sell it for $10, so their value is only $10. This worker only has a value of $10 for the firm because that's the additional revenue they can help bring in. Why would you hire someone for $15 if they're only going to bring an additional $10 in revenue? That's a loss of $5. So this does not make sense. So hiring the sixth worker does not make sense. Now here's something I want to point out. And I notice this a lot when it comes to profit maximizing quantity or hiring workers. Is remember we said the rule is MRP should equal MFC. Notice here that they don't equal to each other. There isn't one where they're exactly equal to each other. And this makes students uncomfortable at times. But really you need to put yourself in, you really need to think in terms of common sense. They intersect eventually. They may or may not intersect at a specific worker or whatever it is. That's simply a stopping point. But here, let's just compare these two. Obviously, they intersect somewhere between these two, right? Because we go from 20 to 10. So it occurs somewhere here, but before we get to worker 6. So yes, these two numbers are not equal to each other, but this is the profit maximizing quantity of workers to hire, because at 6, the marginal factor cost will be greater than the marginal revenue product. At 6 workers, it's going to cost more to hire them than additional revenue. So somewhere in between 5 and 6, these two curves would intersect on the graph, and that's where we would stop, which makes this the correct answer. So don't necessarily expect these two numbers to always be, you know, neatly equal to each other, right? Real life is more complicated than that. And so at that point, that's when your common sense kicks in, right? Um, Obviously, I want to hire workers as long as they bring in more revenue than they cost. Here they do, here they do not. Okay, so hire 5 workers. That is the profit maximizing quantity of workers to hire. Okay, all right. So a few other things to keep in mind here. Some terms. First of all, you may see this term derived demand in the context of labor markets. Pretty much fancy term, meaning the only reason that firms demand labor or any other input is because consumers demand the output, right? Um, so that's where the demand for labor comes from. So we sometimes call the demand for labor a derived demand. In other words, firms don't need workers. Firms don't demand workers just for the sake of hiring workers. Their demand for those workers is derived from the demand for the output. Okay. Now, what that also means is that if consumers demand less output for any reason, then firms will demand less labor. Okay, and this again makes sense. If fewer people go out to eat or go out to restaurants, there's going to be less demand for waiters and other restaurant staff, right? So because again, the demand for that type of labor is a derived demand. Now, for a firm itself, um, what determines their demand for labor? And as you will see, it really is just the marginal revenue product. The marginal revenue product, by definition, is a firm's labor demand. Um, those are one and the same thing. So you may, if you think back to the last lecture, remember I told you that the supply curve really is the marginal cost curve. Well, now the firm's demand curve for labor is really just their marginal revenue product curve. It's one and the same, right? Because again, why do they demand labor? Because consumers demand that output. So depending on how much additional output that they can generate and how much that can be sold for, will determine how many workers the firm will hire. Right? So just think of labor demand as the same as MRP. And I'll show you what that looks like in a second. All right, so labor demand then, which is again MRP, can shift. Generally speaking, there's 3 shifters. Again, changes in consumer demand for the product. So again, if fewer consumers want the product, there's going to be less labor demand. Now, why does this happen in real life? If consumers want less of something, and I'll sort of explain how this works. If consumers want less of something, they'll start buying less of it. That's going to make the price go down. Now, what does the price do to MRP? Well, if the price decreases, then the marginal revenue product decreases. That is a decrease in MRP, which means it's a decrease in demand for labor. And you will see what that looks like in a second. So if consumers want less of something, price will go down. That will reduce the firm's demand for labor. Changes in productivity of the resource. So if workers become more efficient, um, the marginal revenue product would actually increase. Because again, marginal revenue product is marginal product times price. So efficiency, think of it as marginal product. Marginal product goes up, marginal revenue product will go up, and the firm would hire more workers. And I'll show you what that looks like in a second too. But again, productivity also affects marginal revenue product. And then the last thing that could shift labor demand is if there's a change in the cost of other related resources. Um, so this isn't other goods. This isn't output. We're talking about other resources. So for example, what would affect the demand for labor? Well, it might be the cost of non-labor inputs, right? So for example, if the automated checkout machines, right, are sort of a good example of this. As the cost of those things fall, as the cost of the technology of automated checkout and sort of artificial intelligence and all that stuff that's coming up, as the price of those things fall, there might be a decrease in demand for human labor because again, that's a substitute resource that is now becoming more affordable, right? So that can occur as well, and we'll talk about that going forward. Okay, now what about the supply of labor? What determines that? Now, remember, when we're talking about factor markets, everything's flipped. It's now the demand now comes from firms. So it's the firms that demand labor. And households are actually the ones supplying labor. So you want to be careful here. When we're talking about labor supply, this isn't coming from firms. Who supplies labor? And the answer is households. So households are the ones where we get labor from. So what will determine how much um, labor households are willing to supply? Um, And so, number one, obviously, is the number of qualified workers in a specific market, right? So, that, as you will see, that partly determines the, the wage. And I'll give you an example of that in a bit. So, how many workers you have in a particular sort of industry, right? How many veterinarians there are will determine sort of the you know the the supply of veterinarians will determine how, their compensation, right? The supply of brain surgeons versus the supply of unskilled labor. So the amount of workers that are qualified for a specific job will determine the labor supply. Government regulation and licensing can control the labor supply as well. So if there's certain jobs for which you require a license or some other qualification, so if there's any barriers to actually getting into that, like if you want to become an attorney, you need to pass the bar exam, for example, right? So any of these things will limit the amount of workers that actually can enter a certain field, and that would also affect labor supply. And then also kind of personal values about leisure, um, right? So sort of different cultures have different sort of values about, um, the work-life balance. And obviously, if workers are willing to work longer hours, etc., that would increase the supply of labor and vice versa. As you will see, all of these things will affect the labor market and compensation for certain types of workers. Okay, so let's take a look at how this works. So this is how our labor market will sort of look. Vertical axis, instead of being price, is now wage. And on the horizontal axis, we're not talking about the quantity of output. We're talking about the quantity of the input, which in this case is workers. And you have a supply of labor. And again, this comes from households. And we would expect this relationship, higher the wage, um, the more supply of labor, the more workers are going to be willing to supply their time or to work, so to speak, right? So fewer people are going to be willing to work at lower wages, more people are going to be willing to work at higher wages. So that makes sense. But again, supply is now coming from households. And then demand is actually coming from firms. And as you will see, there's this relationship between labor demand and wages. Firms will simply be able to hire fewer workers at a higher wage and be able to hire more workers at a lower wage. So where these two intersect gives you whatever the equilibrium wage would be in a particular labor market. Now, not all labor markets are created equally. Maybe it's $15 an hour for unskilled labor, by which we mean, things for which you don't require advanced technical knowledge. For the market for mechanical engineers, it would be different. For, surgeons, veterinarians, dentists, you name it. There's a certain type of labor supply and there's a labor demand. And where those meet will determine the equilibrium wage, right? So now just think of your labor market as being sort of the reverse of the product market, because now supply and demand are sort of reversed. All right, now in this lecture, we're focusing on a specific type of a labor market, which is a competitive factor market, or specifically a perfectly competitive factor market or labor market. Now, what are the characteristics of that? Well, very similar to perfect competition when we're talking about output. There's a lot of small firms hiring workers. So in other words, there's a lot of employers, right? So workers, ironically, workers have sort of a choice of who they want to work for, right? So there's plenty of small firms, each hiring workers. Um, all the workers have identical skills. So there's sort of an abundance of workers that can be hired, and there's a bunch of companies hiring them, so lots of employers. Um, for that reason, both the workers and the firms that are hiring the workers are wage takers. There's just too much competition in order to pay workers more than the equilibrium wage. And really, you wouldn't be able to pay below the equilibrium wage because there's so many employers that the workers themselves wouldn't work for anybody that's not willing to pay the market wage. So these are all the characteristics of a perfectly competitive factor market. Again, this is kind of the reverse of um, perfectly competitive output market, because now we're talking inputs. All right, so let's see if you can figure out what this will look like. So now, side-by-side graph, a lot like perfect competition. Remember, now we're calling this wage. This is quantity of workers, so careful with that. And again, as I showed you, the supply and demand of labor will determine the equilibrium wage. And now we have our labor market, and then our firm hiring workers from this perfectly competitive labor market. So the question is, what will the firm's graph look like? And this is a sort of a labor graph. It's not output. So first of all, let's think about what does the supply of labor look like for the firm. So let's think about that for a second. Let's say that in this particular market, um, it determines that the equilibrium wage for this type of labor is $15 an hour. So this firm is going to be able to hire as many workers as it wants, as long as it pays the equilibrium wage of $15. So the question is, what is the marginal factor cost of hiring workers? Or what's the marginal cost of hiring workers? You might be thinking, well, isn't it just the wage of $15? And that would be correct. So if you hire one worker, it's $15, but if you want to hire a second worker, it's still an additional $15. So the question is, what's true about the supply of labor for the firm? And the answer is, it's perfectly elastic. This may seem familiar. Remember, in perfect competition, it was the demand curve that was perfectly elastic because they could only sell their output at a certain price. Well, now you can only hire workers at a certain wage. So the supply curve is now the one that's horizontal. Remember, the supply of labor is the same thing as the marginal factor cost of hiring workers, which is the same as the wage, right? So if this is $15, that means the marginal factor cost of hiring workers is $15. Now the question now is, what does the marginal revenue product look like? We'll see if you can remember what the marginal product curve looked like from when we did cost of production. And you may remember that the marginal product curve looked something like this. It was kind of an upside down Nike swoosh. And again, marginal product goes up because of increasing returns. Each worker you hire brings in additional output. Well, now think about it. If each worker adds additional output, that means they also bring in more revenue than other workers. Their marginal revenue product is also higher. So if your marginal product is increasing, your marginal revenue product is increasing because we're just multiplying by price. So those first couple workers are going to bring in tons of extra revenue. And then eventually you have diminishing returns. Your marginal product starts to fall. Each worker starts to add less and less total output, which also means their marginal revenue product is falling. So we get this upside down Nike swoosh here, right? So this is kind of the mirror image of marginal cost. And again, how many workers should we hire to maximize profits? And that is where the marginal revenue product is equal to the marginal factor costs. We don't want to go past that point because what would happen? Well, the cost of hiring an additional worker, let's say $15, is going to be greater than the additional, I don't know, $10 or $5 that worker is going to bring in terms of revenue, right? So there's a reason that we do this when we do perfect competition, and that is this looks a lot like a perfect competition graph. It's just everything's flipped. This is a mirror image. Now supply is households and demand is firms. Again, as I mentioned, the demand for labor is the same as the marginal revenue product. Those two things are the same thing. And the supply of labor is by definition the marginal factor cost. Okay. So this is your perfectly competitive labor market graph. And it's, if you can see the parallels with perfect competition, that tends to be helpful. So here they are side by side, just so that you can see them and notice, how similar they are. So just to review, so for example, the top one here, imagine firms selling oranges in a perfectly competitive product market. So this is price and quantity. Demand is perfectly elastic. The demand is the same as the marginal revenue. It's the additional revenue you get from selling one more unit. The supply is basically just the marginal cost curve, and you should produce the number of units where your marginal revenue is equal to your marginal cost. Now compare that to here, where now just imagine firm hiring orange pickers from a perfectly competitive resource market. Well, they can hire as many orange pickers as they want at one wage. So that's the supply of labor. Now it's supply that's perfectly elastic. And this is the marginal revenue product, which is the same as the demand for labor. So you'll notice this is basically just a mirror image of the product market. So the input market is basically the mirror image of the product market. Okay, so it's kind of useful to see those side by side just so you know kind of what's happening there. All right, so now what the AP exam likes to be able to do is to see whether you're able to sort of manipulate this and to understand what will happen when certain things happen, right? So let's say what happens to the wage and quantity in the market and firm if new workers enter the industry, right? So maybe this was, maybe this could be, I don't know, so more people entering a particular labor market, right? Maybe a licensing requirement was eliminated or something like that. Or more people just want to enter this industry. I don't know, more people want to become dental hygienists or whatever. What is that going to do in the labor market for that particular form of labor? And how is that going to affect an individual firm that hires its workers in that labor market? Well, really, this is just kind of combining things from different units. If more workers enter the market, well, that's going to increase the supply of labor. Now, what will that do to the equilibrium wage? Well, just like any other supply and demand market, the price, in this case, the wage, will fall, and more workers will be hired, right? So if there's more workers in a particular industry, that will put downward pressure on the wage, and more workers will be hired. Now, question is, what does that do to the firm? Well, remember, the firm is a wage taker. If the wage goes down, then that means it's cheaper for them to hire workers from that labor market, so they will hire more workers as well, which makes sense. If each firm is hiring more workers, we would expect the total market quantity of workers hired to increase as well. Okay, so you should be able to do the same thing for changes for fewer workers. MRP can also shift. For example, if workers became more productive or the price of the output changed. So they can throw a lot of different things at you, all of which we will practice for the exam. Okay, but this is just one example. All right, the last thing for factor markets is just another quick rule here on how to hire the right number of resources. And this is called the least cost hiring rule. AP exam likes this for multiple choice questions. It's a quick multiple choice question to answer. Pretty straightforward. This might remind you of utility. If you are deciding to hire between more than one type of resource, let's say a labor and machines, and how many workers to hire versus how many machines, you're gonna want to choose a combination that gives you the most output at the least cost. And there's a way to do that. There's a way to find the optimal combination of two or more resources that's going to give you the most output at the lowest cost, right? And so this is, again, our obsession with efficiency. This is very similar to a consumer that's deciding on the optimal consumption bundle, and this will seem familiar. So let me give you an example. So here's, first of all, the rule. and I'll give it to you as a formula, and I'll explain what's going on here. Um, if you want to hire two different resources, you want to hire the combination where the marginal product per cost of that resource is the same for both. So for example, let's say we were doing labor and machines. As long as you're hiring where the marginal product of labor um, uh, relative to its price, relative to the cost of hiring labor, which really is just the wage, you want to make sure that that is equivalent to the marginal product per dollar spent on machines, right? And so basically the price of machines or the cost of machines, if you want to think of it that way. So as a ratio, they should be the same. Because think about that. If labor gives me the same marginal product but it's cheaper, then obviously the marginal product per dollar spent would be greater for labor, and I should hire more workers and fewer machines. And if the opposite is true, I'd want to do the opposite, right? And if you keep doing that, because of diminishing returns, you'll eventually reach a point where the two would be equal, right? Because if you hire more of one, because of diminishing returns, the marginal product will fall, and therefore the marginal product per dollar will fall. So as you can see, this is the exact same rule as it was for consumers. Remember, it's a marginal utility per dollar, and now it's marginal product per dollar. So really nothing has changed. Um, it's the optimal decision for firms just as it is for consumers. So let me give you a quick example of this just to wrap things up. Let's say you're choosing between machines and workers. Let's say machines are more expensive, so let's say they cost you $10. Workers cost you $5. What you will notice is that machines, for the most part, or at least for the first couple, may be more efficient. But again, they're more expensive. So the question is, how many workers should I hire, and how many machines should I hire? And let's just apply the rule. The first thing you want to do is calculate the marginal product per dollar. So all you need to do is take the marginal product. So if the first machine brings in 30 and it cost me $10 to hire, then that should tell you I haven't got to that point yet. That should tell you the point that we should hire. So let me give you a budget here, just like I would for consumer. Let's say the firm can only spend $35. What combination of robots and workers will maximize the firm's output? Okay, and I'll just do this one with you here. Again, $10 is the cost of um, the robots, and $5 is the cost of labor, right? But we don't care so much about the marginal product so much as the marginal product per dollar spent because they have different costs. This lets us compare apples to apples. So let's just kind of spend the marginal dollar here, right? So for the first sort of hire that we'll make, well, workers gives me 4 per dollar, and robots give me 3 per dollar. So obviously, I'm gonna hire a worker first, and then they'd be the same. So I could choose either one, and it wouldn't affect which way I do it. I could hire the second. Let's say I hire 2 workers because again, there's no benefit to hiring the first machine there. But then when it comes to hiring the third worker, well, I'd rather hire at least one machine because I'll get 3 per dollar, in terms of output, which is greater than the 2. But then these two are equivalent, and again, I can, you know, choose whichever way I'd like. As you can see, regardless of what order I do it, I'm going to end up hiring 2 machines or 2 robots and 3 workers. Now notice that the marginal product per dollar spent on hiring each of these 2 resources is the same. And that is again the key, that is the indication that I am hiring the most efficient combination possible, right? Because if I were anywhere else, let's say, here and here, well, this would give me more marginal product per dollar than that. So it makes sense to 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 not hire this third worker and hire, the second worker instead. So that's the key. These two should be equal, exact same rule as it was for utility maximizing, except now it's sort of output maximizing for a firm. So very similar rule, just as useful. Okay, and with that, that wraps up this last lecture of Unit 3.